Right. Good morning, everyone. Welcome to one of our, I was going to say legendary Azure webinar series, but I think this is number 4 and number 5 that we've done so far on these. So we are getting there in terms of the numbers that we're doing. And obviously, if you've not been here before or not viewed one of these webinars before, welcome. It's good to have you along. My name is Chris Kirk. I'm a senior cloud consultant here at Ultimate Business Solutions, and I'm pleased to be joined by one of my esteemed colleagues, Mr. Alex Kravat-Ball, who's also a senior cloud consultant here at Ultimate Business Solutions. And we're here today just to spend a little bit of time talking to you about some more kind of advanced or nice little features that exist in Azure that you may already be using but want a little bit more information around, just to kind of clarify kind of your understanding, or maybe some features that you're not quite aware of that might add some nice value adds to your Azure implementations that you're either thinking about doing or you currently have in process, or improving those existing implementations that you may have as well. So what we try to do with these webinars, like I say, is we try to pick something from all walks of life in terms of Azure. There must be about 180 or more products in Azure these days in terms of what we can pick, and that is just the Microsoft-based products. There's obviously third parties that feed into that as well that we do talk a little bit about, and we as a business partner with them as well in order to get the best out of the platform for our customers. So what we're going to talk a little bit about today is we're going to talk a little bit about Azure Load Balancers. So we're going to talk about high availability and how that feeds in general in Azure, and then how Azure Load Balancers work and how that can kind of feed in on top of that as well. We're going to talk a little bit about automation with ARM templating. So if anyone has kind of started using the cloud in anger, then you will quickly realize that automation becomes quite key and quite critical to a lot of implementations in Azure. So we're going to talk a little bit about that, a little bit of an introduction kind of around that in terms of if you've not come across it before, how it works, why you would do it, what are the reasons behind looking at something like this as well. I'm then going to hand over to my colleague, Alex, who's going to talk a little bit about Azure File Sync. So if you've been to one of these webinars before, we have covered File Sync before, but like any kind of technology in Azure, change and improvements are rapid, and there's been quite a lot of new features that have been added to Azure File Sync fairly recently. But we'll do a bit of a quick recap for people that haven't come across File Sync before, and then Alex will then obviously talk about the new features that have come into come into the fray in terms of Azure File Sync. So to kick things off, as I've already mentioned, with Azure Load Balancers, and to kind of set the scene a little bit in terms of general Azure Load Balancers and kind of what we're doing with this, we just need to talk a little bit about an architecture that we might commonly have for a setup in Azure. So most architectures that we see, and obviously this is quite a simplistic view, is there will be a user accessing a web server that might reside on the Azure VM that has a backend database, either as a VM or a PAS-SQL database as a backend that obviously talks to the web service that talks back to the user. So from a high availability perspective, before we even get down to what the load balancer will give us in Azure, we have to look at general availability for our services anyway. So if we're having that virtual machine on standard HDDs for that Azure VM, then you don't get an SLA in Azure for that as a standalone VM running standard HDDs. So what that means is Microsoft won't guarantee any uptime for you for that virtual machine if it's running standard HDD disks for the OS or for the data disks. So what we see for a lot of customers, and what we generally recommend, if this is a production service, then we recommend at least premium SSD, not just for performance, but for a single instance, you get a 99.9% SLA on top of that as well from Microsoft. So again, what that means is you're going to get an uptime guarantee from Microsoft that 99.9% of the time that virtual machine will be online and up from a Microsoft perspective. What that doesn't equate to, though, is any kind of patching that you do on that VM, any improvements, any configuration changes, anything like that. That VM is still a single point of failure, and that's where the architecture changes slightly, and we start having multiple instances of this web server that we're going to front, in this case, with an Azure Load Balancer. So the idea being is the user hits the load balancer, and then we load balance those for those front-end services accordingly, as what's referred to as back-end services. On top of that, when we have multiple instances of a particular service, we then put it in something called an availability set, generally speaking, to improve our SLAs further. So by putting virtual machines in an availability set, we're going to increase the SLA further from Microsoft's perspective to 99.95% uptime for those particular VMs. And what Microsoft will also guarantee is those VMs will reside on different hardware in the Azure data center or the Azure region, and it'll also reside on different underlying host patching schedules as well. So Microsoft will guarantee that those VMs won't have underlying patching done at the same time. And from a hardware perspective, they won't sit on the same hardware if there's any power problems, hardware problems, anything like that from the Azure perspective. So availability sets improve the availability further, and then we would then have that in conjunction with what we're here to talk about today mainly is Azure load balancers. So in terms of functionality from a load balancer perspective, they can act as two different functions really. So we can have them as an internal Azure load balancer, or we can have them as a public facing Azure load balancer as well. So from a public facing Azure load balancer, we can have multiple Azure public IPs that sits at the front end of the load balancer. And we can have some NAT rules if we really wanted to as well, like any other load balancer available to us. And then they can access the load balancer from the outside if it's an externally facing service. And then we can have some load balancer rules that go to the backend pools, which are going to be our web VMs, our scale sets, or any other kind of VMs that we want to be public facing in that instance. If this isn't a public facing service, that's not a problem. The load balancer can reside as an internal load balancer only, and the front end then becomes internal IPs on your virtual network or on your subnet that resides in Azure itself. So again, you can have multiple IPs for this because you can have multiple load balancer rules for this as well. So you're not stuck with just a single internal IP or a single external IP as a front end. You can have multiple IPs either way you want to do this, if you really wanted to do it that way. So therefore you can have multiple rules and multiple backends residing on the same load balancer itself. It's a bit of a judgment call regarding multiple backend pools and multiple front ends. Some customers like to have separate load balancers, not for functionality or performance, more for management and overhead. Sometimes it's easier to keep track of changes and kind of what the load balancers are doing by having separate load balancers for separate applications or functionality. It's a bit of a judgment call when you design this, as opposed to anything to do with kind of performance as well, because this auto scales behind the scenes. You can have up to 1,000 backend pools with this if you really wanted to on that side of things. So in terms of how this actually kind of works from a back-end pool perspective, we've got two little services that sit in Azure Load Balancer behind the scenes that helps its work. So we have something called a health probe, which responds to a port as a TCP port, or a response to HTTP, or a response to a HTTPS-based path if we're using IIS, for example. And that's going to basically poll that path or that port in terms of availability, and you can change that interval to whatever suits you from a performance perspective. But the default is every 5 seconds, it's going to poll that path or that port, and if it has 2 failures in succession, then it's going to drop that backend VM out of the pool because it's declared it as unhealthy on that side of things. So that's how the health is managed from a backend pool perspective. From a load balancing rule perspective, we need to define the health probe first, and we need to define our backend pools and our front end IPs before we can set up our load balancing rules. So that allows us to then define the port that we're going to from a load balancing rule perspective, the backend that we're going to from a load balancing perspective. And we've got some advanced features around this as well, such as session persistence we can do with this. And if we're using this from a Azure SQL perspective, for things like availability groups, for example, in Azure, then we have things like floating IP that's available to us as well as an advanced feature. So out of the box, this has a lot of functionality that you'll be probably familiar with if you use a load balancer day to day, such as a Kemp load balancer or a Barracuda or something along those lines. But it's a native PaaS service that resides in Azure itself. So from a performance perspective or a functionality perspective, it auto scales, it's HA by default. You don't have to manage multiple instances of that load balancer like you would with an on-premise load balancer. It's all of that built in under the covers. And we can also do a little bit of monitoring as well, as you can see here on the screen. So using the built-in Azure monitor service that is native to Azure these days, we can set up monitoring rules for things like data path availability, i.e. the path availability to our backend services, the health probe status. If the health probe becomes unhealthy, we can monitor that. And we can monitor our general data into the byte and packet count and SYN count as well, into the actual data flow that's going to our backend pools as well. So just because the load balancer is part of an Azure service, we still get monitoring available to us if we so need that as part of our service as well. So just to highlight a few general features that I've already spoke about some of these kind of already. So it's designed as a layer 4 load balancer in this case, a TCP and UDP based load balancer. Like I say, it exists as private or public. If you select it to be a private load balancer, i.e. it's an internal load balancer, and then you decide you want it to be public, you can't mix and match that, unfortunately. You can't have public IPs on a load balancer with internal IPs as the front end. You'll have to have two separate load balancers in that case for functionality reasons, and you also can't convert an internal load balancer to a public facing load balancer as well. So when you're building these, just make sure you do a little bit of thought up front in terms of what the load balancer is actually going to do for you and your setup before you pick which load balancer type you're going for, either external or internal, and make sure you're kind of happy with that choice. And if you need multiple load balancers, if you're going to mix and match kind of external and internal services from a load balancing perspective as well. We've got two SKUs available to us. So Alex has kindly reminded me and reminded everyone else, if you go for the basic SKU, then they are free in Azure in terms of cost. There's no real cost behind them. But if you go for the standard SKU, then there are some costs, which I've got in the slides shortly as well. But Microsoft are kind of edging towards standard now being kind of the recommendation, in terms of it has better HA performance behind the scenes. It has general better performance than basic behind the scenes in terms of load balancer performance, and you can have much more backend pools in a standard SKU based load balancer than you can with the basic one as well. So if it's not an official guidance from Microsoft, but it feels from our perspective that that's kind of where Microsoft are kind of pushing people down, is to use the standard over the basic SKU based load balancer at the moment. As I already mentioned, HA for this is built in, so it gives you kind of a nice reduction in management and overhead versus what you might be doing for a load balancer on premise. You get 99.99% SLA from the load balancer itself, as long as you have two healthy VMs behind the scenes as a backend pool. Like I mentioned, up to 1,000 backend pools are available on so that'd be for the standard SKU in that case. Multiple different health checks we can do from port to path, depending if we're using IIS, for example, or not. Monitoring, as I already mentioned, we can do that with some thresholding and some alerting as well. We've got our advanced features, such as session affinity, session persistence, and it also does draining of the backend pools as well. So if you are doing any maintenance with your VMs at the back end, it will intelligently drain those backend VMs for you if you take them out the pool. It won't just take them out as soon as you command it to do so, and maybe cause a few kind of problems. If there's a session kind of already being redirected by the load balancer to a particular VM, it will drain that session away from that VM nicely for the end user, rather than just cutting the cord, as it were, in terms of actually doing maintenance on your particular VMs behind the scenes. And if you are using standard SKU-based public IPs, then you can't use the basic SKU-based load balancer. You have to use the standard SKU-based load balancer if you use standard SKU-based public IPs. The reason we mention that is we have come across customers that use basic static public IPs, want to use a load balancer, and want to use a standard load balancer, but you can't mix and match the two. So it's just making sure that that's just want to highlight that basically, if you are wanting to reuse your basic SKU-based public IPs, because we have come across that a couple of times with a few customers. So in terms of cost, like we mentioned, the basic SKU is free for the Azure Load Balancer, but for the standard SKU, the first 5 rules are priced, as you can see on screen, per hour. and additional rules are priced, as you can see on screen, per hour as well. NAT rules are free. Doesn't matter how many NAT rules you do, they're always going to be free. And there's a slight cost to data being processed by the load balancer as well. But as you can see, it's incredibly low from a cost perspective. So even from just a quick glance at the costs, from an Azure Load Balancer perspective, as opposed to using a third party, it's incredibly cheap, to be honest, from a load balancing perspective and a load balancing feature in Azure compared to kind of other third party solutions. And in our experience, most customers that want to do load balancing, this load balancer, what doesn't have quite all and maybe all singing or dancing features of some third party load balancers, 95% of the time, it covers what customers want to do from a load balancing perspective, with a significant reduction in cost and management overhead in terms of HADR and monitoring to boot as well with that. So we use these in pretty much all of our implementations these days when we're working with customers. We rate them quite highly. We haven't come across any kind of weirdness or kind of any major issues, to be honest, these days. And we see them all the time, to be honest, from a load balancing perspective on that side of things. So from our perspective, we definitely kind of recommend checking it out if you are looking at high availability and load balancing needs for your Azure environment. Just to say as well, if you do have any questions, then we'll save a little bit of time at the end as well. And if you want to ask any questions, feel free to put them in the chat window anyway. But just to say that we'll review all the questions at the end of the webinar if you do have any. But feel free to put them in the chat window as we go along in that anyway. So I'm just going to cover off. Well, I say cover off. I'm going to talk about Azure automation, specifically with ARM templating. Now, I'm not expecting everyone has come across this, or they may have come across it and don't quite know kind of where to use it, and need a bit of a scenario really in terms of where does this actually fit into our day-to-day environment. Where would we actually use this? So if you've seen my little presentation on DevOps, which I've done in a previous webinar, some of these slides may look slightly familiar to you, because the message from the DevOps side of the webinar I did to this is a little bit of an overlap between the two, to be honest. So when we look at a traditional workflow between your developers and the infrastructure teams, there's kind of, generally speaking, a little bit of a barrier between the two of them, where the developers will develop what they need to do from an in-house application, and then they will chuck that over to the infrastructure teams, and the infrastructure team will go about building VMs, the networking, the settings for the VMs. It's quite manual, and it's quite difficult to then go from a development environment to a test environment to a production environment, and to be consistent all the way along, as well as reasonably quick to then spin up that infrastructure. I mean, when I do a general automation kind of sit down presentation with this, I will often ask the room, put your hand up if your test, dev, and production environments from an infrastructure perspective are identical for your testing across the board. They're absolutely identical, and you have a process to manage that. And to be honest with you, not many people actually put their hand up, but it's a very difficult thing to do, which is kind of what we're kind of getting across in terms of what automation can give us. Because the advantage with ARM templating is all our infrastructure then exists as code. So it exists as basically JSON-based files, so it's JavaScript object notation, and we can update that code, and it can sit alongside our application code, and we can audit it, we can track it, we can deploy it to multiple environments. It becomes a lot easier to make it repeatable and consistent across our environments when we're actually doing new systems, or building new environments, or doing development in general for our applications in the cloud. So to give you a little bit of history with this, in terms of how this works in Azure. So when Azure first came out, we had what was referred to as ASM, or Azure Services Manager. So that was the first Azure UI, which some customers may have used already. It was basically the white screen based UI with two banners across the bottom. That was kind of Microsoft's first go at a UI for Azure. And they quickly found that it was quite difficult to automate anything with that UI. Azure PowerShell did exist, but it was very tricky to automate deployments with that, because you had to kind of manage the code very specifically. There was lots of if and else and do and while and do and for each and all this kind of code that you had to manage quite specifically to make sure that that worked correctly from an automation perspective. So what Microsoft decided to do was go back to the drawing board a little bit in terms of making automation key to do our deployments in the cloud. So that's where Azure Resource Manager, or ARM, which is the portal we have today, kind of came along. So they basically redesigned the portal with automation in mind, and the portal is now designed on top of a general REST API, as well as supporting JSON coding as standard. So it's not proprietary. It's a common language that they use. That's very common in the industry these days for doing development. And every time you click a button on anything in Azure, regardless of what you're deploying or configuring, it's actually running a REST API or a JSON-based command in the back end. So the actual portal itself is actually doing the automation, even if you're not at that point. And that kind of took over from the ASM portal around 2014 and 2015 at that point. And it means that we then have the opportunity now to write JSON-based automation scripts, as well as using our Azure PowerShell and writing kind of our APIs for this as well. And from a development kind of IDE perspective, we find that either Visual Studio, if you have that already, or even Visual Studio Code, which is a free IDE from Microsoft, I definitely recommend it. I use it pretty much every other day, if not every day at the moment for doing development. It's a really good free UI, free IDE, sorry, to use, and it supports ARM templating as well as PowerShell work as well. So that's kind of gives you a little bit of history, kind of where we are with this. And we end up with trying to get to this process goal of making changes, testing it, releasing it, monitoring it, making improvements, and kind of getting into this habit of making changes and constantly improving our release cycles of dev, test, and production, not just from an application code perspective, but also from our infrastructure perspective as well. So from a JSON ARM template perspective, the difference between that and maybe Azure PowerShell is it's what's referred to as declarative in nature. You're basically writing in a JSON template, here is what I want you to do for when you look at it, it's quite high level, really. You're telling it, I want a VNet with this many subnets. You're telling it, I want an Azure VM with this many data disks. I want an Azure Load Balancer with this front-end IP and this back-end pool. It's very simple in terms of language to then just say what you want, as opposed to having to put a lot of effort around syntax and process and order around everything. And we can deploy those templates either via the Azure UI itself, via the portal. We can do it via Azure PowerShell. We can do it via DevOps-based solutions such as Azure DevOps, for example. And in terms of kind of this repeatability, it supports two different modes. So it supports what's referred to as incremental mode or complete mode. So incremental mode basically means that if you make changes to the ARM template, it will only deploy those changes and skip everything else that's already been deployed. Where complete mode will basically remove everything that it sees already that's been deployed, and it will deploy everything from scratch again. If you want to just basically blow away what you were doing for whatever reason and deploy that from scratch. Like I say, what we're trying to do here is we're trying to construct either core parts of an environment or an entire environment from a single template, and it gives us that repeatability and that consistency and speed, basically, from a deployment perspective. It removes any kind of user error that we're dealing with here. Not that we do it on purpose, obviously. Yeah, I'm an infrastructure guy day to day as well. We don't do mistakes on purpose, but we're only human at the end of the day. And this kind of removes that risk and that element of that as well. And how we divide these templates up from a coding perspective, we generally have two files. We have our parameters file, and we have our ARM template file itself, which is divided into kind of three areas, which is parameters, variables, and the resources, the Azure resources that we want to actually deploy. So just to make it clear from an incremental mode perspective, say, for example, I deploy a template that deploys a VNet, an app service, SQL database, a VM, a load balancer, for example, and I then realize, oh, I've missed off the backup vault. I need a backup vault for my Azure VMs. I'll add that resource into the ARM template, I'll redeploy it, and it won't touch the deployments that have come before that. It will just add in the backup vault for me as a resource for that environment itself. So it's a nice, easy way of doing the repeatability and not touching the stuff that you've already done as well, and adding bits in kind of as we go. So to give you a little bit of a sample what this may look like from a parameters file and an ARM template file. So on screen, I've got a very simple parameters file here. So I'm using an ARM template to construct a VNet in Azure with a particular subnet. So from a parameters perspective, I'm defining the name of the VNet, where it's going to live in terms of a region, what resource group it's going to live in Azure, the address range of that VNet, the name of a subnet. In this case, I've just got one, which is called default, the prefix of that subnet, and do I want to enable DDoS protection? Yes or no, basically on that. So I define the values that I want for my resources in a parameters file, and then I feed the parameters file into my ARM template. So when you deploy the ARM template, it asks you for those two files. It will ask you for your parameters file for this deployment, and it will ask you for the ARM template for this deployment, and it will automatically feed the parameters file into the ARM template for you in terms of those values. What we then need to do in the actual ARM template itself, we need to define the parameters that we have already got values to in the other file. It will then pull those, it will then go and look for those parameters from the other file, pull them in, and then it will then define the resource. In this case, I've got a VNet resource that I'm constructing, and I can feed the parameters into that resource in terms of things like location, for example. So you can see on the example on screen that under the location line, I'm defining a parameter of location, and that was the location I defined in my parameters file. Now, I appreciate from an infrastructure guy perspective, this can look slightly daunting to start off with in terms of how this code works, but trust me from experience, once you start using this, after the second or third go of playing with this, it becomes quickly familiar in terms of how this works. It looks slightly daunting. It's not kind of your real world kind of thing, but it does make sense after you have a go at this after about 2 or 3 goes from experience. I started using this in anger probably about 2015, 2016. I was unsure myself, to be honest with you, but I deploy this pretty much every engagement I do, or every reasonably sized engagement I do, rewrite ARM templates for customers now. So the idea being is we can then deploy those resources back if they get deleted, or you need to redeploy them for another environment, for example, for that speed, repeatability, and consistency on that side of things as well. So as I've already mentioned, in terms of deployment, we can do it via the Azure portal, or we could do it via Azure PowerShell if you really wanted to. So just to give you a quick example from the Azure PowerShell perspective, how that actually works, we can log into Azure using Azure PowerShell, select the Azure subscription that we want to deploy into. We define the path for the parameters file, the template, and the resource group that these resources are going to live in Azure. And then we have 2 commands that we're going to use, and you'll end up living and breathing these commands, trust me, from experience. One is a test command, and one is a new base command. So the test command will basically look at the ARM template and the parameters file and the resource group, which has to exist for this command to work, and it will check the syntax, and it will check that that template is valid, but it won't actually deploy anything. So we always recommend using this command when you're deploying stuff, because it's going to do a quick check of your template to make sure it's actually valid before you deploy anything, and it will come back and it will let you know, yep, that's all good, I'm happy with that, syntax looks valid, away you go. And then from there you can run the new command, and that will actually do the deployment for you into Azure from a PowerShell perspective. So from a kind of process, this is what I end up using most of the time, to be honest. I use the Azure portal occasionally, but from a PowerShell perspective, this is what I use most of the time in terms of doing my deployments, if I'm not using something like Azure DevOps, which obviously has this kind of stuff built into it as well. So just in summary, on ARM templating perspective, we're doing this for speed, we're doing this for repeatability, we're doing this for consistency. Visual Studio Code is free as an IDE. I recommend you check it out. It's not just for ARM templating, it supports multiple languages, including PowerShell, as well. It does IntelliSense, it does autocomplete. It's come a long way in the last year, especially from a free solution from Microsoft. If you didn't see the DevOps presentation, I recommend you check it out on our YouTube channel and have a bit look at that, because I talk a little bit more about this in terms of the reasons behind automation and why you should use things like the Azure DevOps tool. And for a lot of reasons, it gives you the ability to track changes and do proper auditing when you're doing your deployments around this as well. But if you're kind of new to this and you're kind of getting started, I recommend checking out the quick start template that Microsoft have put together on GitHub. So if you just Google or Bing, if you're Microsoft inclined, you can search for Azure quick start template on GitHub. The URL is here as well, and that will give you level 100, 200, 300 style templates on common scenarios that Microsoft feel that a lot of customers have done, and that will help you kind of get started, and you can have a look at these ARM templates, play with them, put them in a test environment in your MSDN or something like that, and kind of live the dream basically in terms of automation. I love it. I think it's really good. And if you want to know more, kind of speak to the account manager. A lot of our cloud consultants know this pretty much by heart. And if you need some automation in your life, yeah, feel free to get in touch on that side of things. So what I'm going to do now, I'm going to hand over to my handsome colleague in terms of talking a little bit about Azure File Sync. So bear with me, we're just going to swap screens.
So hopefully you should all be able to hear me and see my screen, which is excellent. So don't worry, guys, too much if it scares you, all that Azure automation. It scares me too. I think Chris is more on message, and he's younger than I am, whereas I come from the days when we all used to do DOS and command line, and then Microsoft introduced a GUI and told us all to forget command line, don't worry about that. And now 20 years later, they're going, actually, you know, that GUI thing, we'd rather you just audit it in command line again. So I'm sure it'll all turn around in another 20 years and we'll be back in the GUI. But of course, everything, you know, Chris is talking about, you know, 90% of it you can still do in the GUI. Depends how much you want to drink the Kool-Aid. We have two different slight opinions.
He's learning slowly. Don't worry about it.
Yeah. So what I'm going to talk to you about today is more traditional infrastructure and what we call more of a hybrid cloud. Some of you are familiar with Azure Files already, but I guess it's sort of using those on-premise technologies that we already have and extending them into the cloud and taking advantage of some of the cloud benefits. So let's talk about the good old days and the traditional world where, yeah, 20 years ago we had our NetWare, and we still do today have our home drives and our public drives and our data drives sitting on great big file servers on premise. And a lot of those file servers have grown. So I go and see customers that I've been seeing for years, and they might have up to 100 terabytes on a file server. And maybe 10 years ago, they had like 30 or 40 terabytes. Or some of them probably had 1 terabyte 10 years ago, and now they've got 30 terabytes on a file server. That's very common. And that growth is meant that they have large storage costs, and on-premise every few years, 3 to 5 years, they have large capital costs when they go out and buy a new set of HP or Dell or Fujitsu servers, whatever it may be. And of course, with that large data growth, we've also got enormous amounts of backup data to look after, move, contain, store off-site. And DR, we've got to also have that data available if a disaster happens. I find it's kind of really interesting as well, is that even though that data sort of belongs to the users, it's always sort of kept responsibility on the IT department to decide what's needed and how long we keep it for. And that's very difficult to kind of push back to the users. And what we've ended up with is tens of terabytes of data that we just keep, even though 80% of it's not used anymore, and we have it in different places. The other kind of big driver we see for Azure files is perhaps some people have sort of followed Microsoft's initial recommendations of moving to a store simple, which is a SAN or a NAS box, if you, as well, in different forms that can hold a lot of your data and tier it to the cloud. And Microsoft are going into support in 2020 on these store simples, so they're going to bring out haven't really told us what it is yet, what their absolute migration path is going to be, but we believe at the moment it's going to be Azure files. And also with these traditional servers that we might have on premise, we've got patch management, security updates as well. So those are some of the traditional pain points that we see in our existing environments. So how does Azure files help us? So what Azure files is, it's very much a PaaS service, so we don't have to worry about that underlying patching and security updates that we would have in our on-premise environment. Azure files is giving us a file share directly in Azure. So when all we're seeing is the files, and we're not seeing any of the infrastructure beneath that, like RAID sets, and NTFS, and logical disks. That's all hidden from us. We just have to kind of create a share, and off we go in the Azure files world. So with Azure files, it's SMB file share sitting in Azure. It also has a REST API to it as well. It's secured. It's got encryption at rest. It supports SMB3, and you can have sort of multiple sets of these Azure file shares spread across different Azure geographical regions. I always like that. So I'm not one to sort of bear away from the, what's the gotcha with it? Well, at the moment, it doesn't support those sort of complex NTFS ACLs that we have on premise at the moment, where we have different teams with different group memberships that have access to different sets of files. At the moment, if you can access a share that's sitting in Azure, then you've got sort of access to all the files in there. So that's kind of the stage one. What we've got built on top of Azure files is Azure's file sync. And this is really what we are seeing as the most popular kind of use of Azure files. And the reason around that primarily is around that sort of SMB ACL support that we still need for a lot of applications. So what are people doing in the real world? They still need the ACL support. Some of them, though, with these big on-premise file servers I talked about, are moving some of that. They might have a big public drive that might move into a SharePoint server. A lot of you got Office 365 and you're allowed a certain amount of data sitting in SharePoint, and some of those home drives are moving into OneDrive for direct local access that's synced with your laptop or desktop. But a lot of the time, people are also going for this hybrid option, which is Azure File Sync layered on top of Azure Files. So what is it? You have your Azure Files, your share sitting in the cloud as you would traditionally, and then on premise you have your Azure Files server, your traditional file server that you have, and you install an agent on it. So it could be anything from Windows 2012 R2 up to Windows 2019, and you put this agent on it. What this agent effectively does is tier data. So it's looking at how often data is accessed locally on that file server, and data that's not accessed often is tiered into the cloud. So you can have a full copy of your data stored locally. What most customers do is they have a smaller investment on site, so a smaller server with a smaller amount of disks in it and smaller storage, and they keep the most commonly accessed, most regularly accessed data locally, and then stuff that's not accessed so regularly is up in the cloud. To the end users that are connecting to that traditional file share, it's transparent to them. They don't realize that not all the files are local to them. They may realize, of course, if they download a really big file, it might take an extra second or two for the file to appear for them. To open, let's say they're opening a big PowerPoint or a really big Excel spreadsheet. But in that file server world, we're not so sensitive about latency. Well, let's see, what are the other requirements? 2 gig of RAM, so your file server's got to have at least 2 gig of RAM, it's got to have NTFS. It does now work with deduplication, and if you're using sort of the traditional NTFS compression, you can use that, though we tend to find more customers are using Windows djig now. And you can layer DFS above as well, so if you're using DFS namespaces. Not DFS replication, Microsoft are really seeing Azure file sync is actually a replacement for DFS replication. You can't use BitLocker with it yet, or encrypted files shares. So it's quite popular. It fits, 98% of use cases for on-prem servers, and it's very good for branch offices as well. So if you've got lots of smaller branch offices, and you don't want to have the hassle of backing that data up or DRing it because you might not have permanent IT people on site. That's another use case for it. So let's say you've got your small branch office. The data, you have everything synced up to the file share, and then the backups all happen in Azure. Where's it available? Both the UK data centers and the other European data centers, which are obviously gets right, Dublin and Amsterdam. All the other regional kind of big US ones support it as well. So what's the scenarios that we see it used in most often? So multi-site sync. So you might have multiple remote locations that all need access to a similar set or the same set of files. So you can have your one sort of file store out in Azure, and then multiple geographical local sets of the data. Works pretty well. There is a gotcha. So there's no centralized file locking at the moment. You can layer third-party tools on top that will give you that centralized file locking. But yeah, so that option's there. Though I find in the real world, it does happen that you have 2 geographical locations that need access to the same files, but it's not as common as you'd think. So tiering's the other one, where as I've mentioned already, you don't want a full set of data on premise. A scenario might be, let's say you've got an on-premise file server and it's running out of space, and it's a relatively new server, and you don't want to spend a load of money putting new disks in it or getting a whole new server. You can put this agent on, it'll tier it'll copy all the data initially into the cloud, and then it'll start tiering what you have local. So effectively, you're not having to spend any more capital budget. If we kind of imagine that we've just got the SMB share up in Azure and we don't necessarily have the on-prem local file server, you have customers do run applications up in Azure that still need a CIFS file share, and they can write directly to that. Integrated cloud backup is the big driver for it. We find that with the enormous growth of files on premise, backing them up and DRing them is a real pain. And so by having a copy of this data in the cloud, all the backups are done in the cloud. You don't have that pain point on premise. You also don't have to worry about necessarily, if you're just using SMB shares in Azure, you don't have to worry about patching them. And it gives you the rapid DR as well. So if your on-prem file server fails, you could install that agent on another file server. It could be a file server in Azure. You might have it already on a second file server. It may be in a different location. And you can say, right, I want to be able to see those files. And all it does is initially bring down the metadata of all those files. So if a user clicks on the share, the file might take a little longer to appear, but they'll get the file and it'll start building the local cache up again. You don't have to wait for all those files to kind of reappear locally on a local file server. So how do you actually implement it? So this one's a little bit more techy. One of the stages to implement it, well, the first thing you do is you create a storage account in Azure, which is about 3 clicks. And then within that storage account, you create what's called a container and In this case, it's really a file share. So under Azure Files, you say, I want a file share, you click go. And at the moment, when you do this, standard file share has a limit of 5 terabytes on it, but by the next couple of months, they're going to raise that to 100 terabytes. I should say that there is actually a premium version of Azure Files for really fast, low latency access. Obviously, it costs more money, and they already have 100 terabyte file shares available. The next thing you do is you go to the Azure portal and you create what they call an Azure File Sync resource, and you give it a name, and so it creates this storage sync service. Once you've done that, you go into your storage sync service, and you create a sync group, and it says, oh, this group, what file share do you want it to match up with? And you match it up with the file share that you've already created in the storage count. So there's a drop-down box, and you go, I want that one, please. And that creates what we call our cloud endpoint. So what we've said is, I've got a storage account with a file share, and that's a cloud endpoint that I'm going to connect up to an on-premise file sync agent. So the next step is to install the agent on your on-premise Windows file server. If on-premise you haven't already got any shares, or what you start, let's say it's a brand new file server, you would create some file structure perhaps. So I would perhaps create a D share one folder as a basis. Because what I'm going to do then, as the next step, I'm going to go into the Azure portal, I'm going to add an endpoint, and it's going to say, okay, the cloud endpoint is the share that you created in Azure called share one, and I'm going to say, right, and that's going to match up with my D file one folder on the file server on premise. And it is that easy. You don't have to worry about deploying templates or doing anything on the command line like Chris says. You can do it all through the GUI. It's very simple to do. Okay, so where do we stand with Azure File Sync? Like a lot of things in Azure, it's rapidly changing. So Microsoft's had these incredibly quick development cycles now, when new features are coming in all the time. So I've mentioned already, we've got introduced something called premium files, which gives us incredibly large file shares at the moment and very low latency SSD-backed storage. I do see a use for it, but it's a bit fringe in that you're paying a lot more, and traditional kind of file services that were never originally designed around low latency, very high I/O. So the use cases that are built up over the years tend to be quite low. What they have done is enable more capacity and transaction metrics. So in Azure Monitor now, you can see very well, a lot more clearly than you used to be able to, what capacity you're using in the storage accounts with Azure files and what sort of throughput you're getting from them and how many requests you're getting. You get the LRS, ZRS, and GRS. So what that means is, on our backend storage account, LRS is our kind of all the data stored in one location, one data center with 3 copies. With ZRS, what they're saying is, well, it's in the same geographical location, so it might be UK West, but we're going to kind of put 6 copies of the data, 3 of them in one building and 3 in another building. And GRS is the next step up, where we're actually going to say, well, if you've got your data in UK West, we're going to put another copy of it in UK South. So it's in a completely different data center, different part of the country, in case there's a full outage. And rules of thumb is, if this is your kind of master copy of the data, you probably want to have at least ZRS. Because worst case scenario, if Microsoft lost let's say, a physical data center, it burned down. If you had ZRS, it would be in a different physical building. Offline data transfer. So a lot of customers, as I said, have a lot of data, and that initial kind of loading of that data up into Azure can be quite slow and painful. So what you can do is Microsoft will send you a NAS box. You plug it into your network, copy the data onto it. I'm simplifying this a little bit at a high level, but it is pretty darn simple. And then you send the NAS box back to them, and they copy a man in a van, post it back to them, secure UPS type delivery. They take it into their data center, upload that data onto the storage account for you. So you've effectively preceded the data transfer. They've added an extra kind of tiering option. So if you're tiering, which most customers do with Azure File Sync, that local on-premise, which is the way you used to do it, you'd always say, right, I want to have, say, 40% free on my local disk. So that would mean that it would always sort of, once the drive hit 40% or less free, it would start tiering the files up to Azure. Now they've also added now an extra option which says, really what I want to keep in my cache is only files that are modified in the last set number of days. So you might say anything in the last 2 months, any file that's been touched, modified in the last 2 months, keep it locally. Everything else, shift it up to Azure, please. Which is quite a nice functionality to have. You get a bit more control over which files are stored locally. What's next? What's coming? I'm sorry, I'm going up too quickly. Is we're going to have 100 terabyte shares in standard, as I mentioned. So it's in sort of it's in private preview at the moment, I believe, still. So it's not quite in public preview yet. They go through stages: Microsoft private preview, public preview, and then GA, where anybody can get their hands on it. So private preview, you have to sort of fill in a form and say, I want access to it. Public preview, anyone can kind of request access and they'll get it. And general availability is out there for everybody. I think what's also in private preview at the moment it's in public preview. So you can actually control your backup of Azure files through the traditional recovery service vault interface that we have for virtual machines, SQL, that sort of thing. Storage account failover. So what they're kind of enabling an extra level of resiliency, so that a storage account that sits in Azure, they're going to be able to sort of seamlessly fail over to a second copy of that storage account that sits somewhere else. So let's say an whole Azure region gets lost, but your on-prem file server is still okay. Your on-prem file server will just be able to connect up to a copy of the data that's in another region. So let's say UK West fails, your file server that's on-prem in London would automatically seamlessly talk to UK South. Users won't know that there's been any sort of problem. What have we else? Well, what's up next? RAGRS. So this is a kind of feature whereby you actually have a second copy of the storage account, which we've already got that availability with GRS, but you can actually, the problem with GRS is you can't actually access that second copy until Microsoft say you can. So with RAGRS, you actually get read-only access to that second copy of the data. What else have we got with Azure? We've got, I think I've mentioned the import tool for moving large quantities of data, preceding it into Azure's data centers. You can pull data out like that as well. And an Azure File Sync evaluation tool. So if you're not sure, you've got a large 20, 30 terabytes of data, and you want to know that that's going to work with Azure File Sync and it's going to sit in Azure all right. If you Google Azure File Sync evaluation tool, it'll take you to a link, and it's basically a PowerShell script that you run locally on your file server, and it tells you yes or no, this is going to work well. I've never come across a problem yet with it. Okay, so I just want to kind of actually talk about something that's related but isn't so some of you may be NetApp customers already. There's a feature called NetApp Cloud Volumes, which is effectively a NetApp sitting in the cloud. And the reason why I brought this up is a lot of people who have NetApps on premise, NetApps act as a NAS box and serve up files in a CIFS SMB format. So some customers have migrated off of traditional file servers on premise and moved to these NetApp NAS boxes. And effectively, in that sort of scenario, we've got customers who then want to protect those on-premise file servers from a GR perspective. And what we've found is what suits them very well is they have a virtual NetApp sitting in Azure, and they can replicate those on-premise cloud volumes actually up to Azure. And they used traditional NetApp replication technologies called SnapMirror. So this is just an underlying, works at the sort of disk level, replicates data around between NetApp files, NAS boxes, including the virtual one in Azure. It'll do, so you can also do some tiering. So talking about this virtual NetApp NAS box sitting in Azure, you can tier data from your on-premise NetApp up to the NetApp in Azure. The one in Azure supports SIM provisioning. It does all the traditional NetApp technologies that some of you are familiar with, deduplication and compression, which can reduce your effectively your storage footprint in Azure by 50 to 70%, and hence reduce those costs related to storage as well. It supports SMB CIFS. So what that means is your traditional NTFS ACL permissions that you had on premise, you can also have in Azure, and it supports NFS as well, which is like the Linux NAS protocol, if you like. And it also does the traditional NetApp snapshot protection technologies, managed through something called Snap Center. So it's a bit like NetApp's way, its story around doing backups, is to actually create a snapshot and then replicate that snapshot offsite somewhere else. And if you're a NetApp customer, you're probably already using that technology. Effectively, what we've got here is another NetApp, but it's just sitting in the cloud. You deploy it through the Azure portal as you would with other functionality. And lastly, there's another. This is actually, I tend to think of NetApp Cloud Volumes as an IaaS solution, and yet you are actually deploying it's very simple to do, but you're deploying a virtual machine in Azure, which is just running the NetApp operating system called ONTAP. Now they do have a PaaS offering, which is NetApp Files. So this is a bit like the Azure Files. You are just accessing directly a file share in Azure, and it supports SMB and NFS. And what NetApp is saying is it's very, very low latency. You can have it in different regions. It supports NFS and SMB, so it's very like the Azure Files. You can do rapid clones with it, and you can get very high performance. They have multiple tiers, so the highest one, Ultra, will do 128 megabytes a second. Premium will do 64 megabytes a second, and Standard, which is probably what traditional file servers, more like 16 megabytes a second. It's a bit fringe in that kind of why do you need this high performance, low latency? And when you ask NetApp about it, they're really targeting this at perhaps customers who have Linux applications on premise at the moment that do rely on NFS file shares and need high performance and low latency. They might have, one of their scenarios was perhaps database applications that are using some backend sitting on NFS storage. So this is the scenario. I thought I'd bring it up just because some of you may be NetApp customers already, and it links in nicely with file shares. But feel free to ask any questions about that. We've got to the end of the presentation now, so if you've got any more interest in anything we've talked about today, you can contact us directly, or you can ask any questions you want right now, guys. Yeah, fire away if you've got anything.
So I think someone just asked if we were sending out a recording of the webinar. So yeah, absolutely. There will be a recording of the webinar sent out, and that'll be on our YouTube channel, but that will be sent out in correspondence as well.
I hope we did take up, we went a little bit over time, so apologies for that. Okay, have we got an email address, Chris, that people can email in case they have any more follow-up questions?
I think that generally, if you have any questions, if you contact your account managers and take it from there, and they'll then feed back to us if need be, basically. The easiest way to do it.
Lovely. Okay, thanks everyone for joining. I hope you found it informative, and also have a great weekend. Thank you.